Okay, so let's take a look at what our proofs are going to be like in this class. Okay, so a lot of what we're doing is going to show that some expression, let's say for example 2 plus 3, okay, that expression is going to be equal to some other expression. For example, that might be equal to 15 minus 10. Okay, and we need to prove that. Okay, so this is an equation, and what we're going to use is something called equational reasoning. So that's our main style of proofs. We're going to reason using equations to guide our design. So in general, we might want to prove that A is equal to Z, okay? And this is the way all our proofs will look like, okay? So I want you to start getting used to this particular syntax, okay? So we'll start by writing A because we're trying to show that that's equal to Z. And so we'll say that is equal to, and then we'll write something that it happens to be equal to. In this case, let's say B. Okay, and we'll give a reason. Okay, so the reason might be, oh, I don't know, but let's just say there's some reason that explains why A is equal to B. Okay, and then we'll say, oh, and of course that's equal to C. And again, there's some sort of reason that explains that. And then it's equal to D. And again, there'll be something that explains why is equal to D. Okay, and we just keep doing that, and eventually we'll get to Z. And that'll be the last reason that we give. Okay. That would tell you why it's equal to y, for example. Okay, so so that's our style of proofs. So the only question that's left is, how do we justify that A is equal to B, for example? Okay, and that's what our main approach is going to be, and that is that we'll allow substitution. Okay, which means we'll just replace of equals with equals. Okay, so that's our only rule. For example, let's start with 2 plus x minus 2, and what I'd like to show is that this is actually equal to x, right? So to prove it, I might start with, well, I always start with the left hand side, so 2 plus x minus 2, that's going to be equal to, and I'll say that this is actually equal to 2, I'm sorry, plus minus 2 plus x. Okay, and the reason that's happening is that I took x minus 2 and I rewrote it as minus 2 plus x. That's commutativity. Okay, and then what are we going to do? Oh, I'm going to say that this is actually equal to 2 plus minus 2 plus x, and that's associativity. Okay, which means that I can change the parentheses. Okay, now 2 plus minus 2, that's simply equal to 0, so I have now 0 plus x, and again notice that this became that. Okay, and that is a inverse. Okay, additive inverse. And now 0 plus x, well, that's just equal to x, which is exactly what we want, and that can be because we're adding null. Okay, so so that's the way the proofs look like. Now these things here, you know, the reasons. Okay, we're going to be very careful about that. I don't want you to stress over that right now. Okay, you don't necessarily remember all of the rules of arithmetic, for example. You just know how to do it. Okay, you've been doing it for many years. So yeah, don't worry about that. We'll be very clear about what we need. But I just want you to see the style. Okay, so now let's take a look at the actual rules that we're going to use for arithmetic. Okay, and here they are. Okay, this is actually all the ones that we'll have for arithmetic. I want to say here, I will not ask you to remember all these. Okay, it's not that they're hard to remember. I think if you look at them, you'll just go, well, duh, yeah, that one's true, that one's true, that one's true. The only problem is that it'd be hard to remember the things that aren't in it, okay, because we just know too much arithmetic. So I won't ask you to remember this. I'll always give you this as a starting place. But I do want us to take a look at them, okay, and see what there is. So look at the first one, x plus 0 equals x, okay? That's really hard to argue with, isn't it? I mean, it's what we mean by 0. And here's the name. The name is plus identity, okay? So when you want to explain why you replace x plus 0 with x, you can say, oh, that's because of plus identity. Okay, here's another one. Minus x plus x is equal to 0. We actually used that one you might recall, and that is plus complement. Okay, this is the actual name of it, is plus complement. So that's what I would want you to use. Again, don't panic. You'll have this sheet when you need it. Okay, x times 1 is equal to x. Yeah, that's exactly what we mean by 1, right? So yeah, that we agree is true, and we call that x identity. Okay, x times 0 is equal to 0. That's something that we all agree with. Times null, that's just the name of it. Okay, x plus y is equal to y plus x. That's the commutative property for addition. X times y is equal to y times x. That's the commutative property for multiplication. Then we have the associative laws. So x plus parentheses y plus z, or z, is equal to x plus y plus z. That's plus associative. Okay, and we have the almost identical rule for multiplication. X times y times z is the same as x times y times z. Okay, and finally we have the distributive law, which I'm sure you might have some fond memories of from just elementary school. This was something that's covered, and I don't know about you, but when I took it, I thought it was a little mysterious. But x times a sum, y plus z, is actually the same as x times y plus x times z. Okay, that's called the distributive law, and these are all the axioms of arithmetic that we actually need. So we can actually use them to do proofs like the one that we just did before.